So let's take a look at the Edco A paper. It's question 9, and this is a question on patterns. We can call patterns sequences. And there's also some algebra involved in this question. So we've been given 3 terms of a sequence. Term 1 is 5x minus 2, term 2 is x squared minus 4x, and term 3 is 5x squared plus 3x. Now it's not immediately apparent what kind of a sequence this is because the terms are given in terms of x. We'll find out in the B part of the question that this is a linear sequence, and in a linear sequence we know that the difference between each term is the same, and we sometimes call this the first difference because we also refer to second differences. In a quadratic sequence, the second difference between the terms is the same. So the difference between each term is not the same, but the difference between the differences is the same. So the second difference is the same. And we would have seen that in a previous question on this particular paper. We can have exponential sequences, and in an exponential sequence, each term is found by multiplying the previous term by a common ratio. So generally this is where we have doubling or tripling, so you're multiplying by 2s and 3s, but you can multiply by any ratio, even numbers less than 1. So that's an exponential sequence. And they're generally the 3 types of patterns that we see in the junior cert. So we're asked to fill out this table in part A to find each of the first differences. So what do they mean, each of the first difference? So they want the difference between the first term and the second term, and then they want the difference between the second term and the third term. So the way that we're going to do that is we're going to subtract initially the first term from the second term. So they have some of this work done for us. You can see it here. And we have x squared minus 4x minus 5x minus 2. So let's just write that again. We have x squared minus 4x, so that's the second term, and from that we're going to subtract the first term, and that will give us the difference between the 2 terms. Now, the reason there's a bracket around the second term, 5x minus 2, is to make sure that we subtract both the 5x and the minus 2. So we have x squared minus 4x minus the 5x, but then minus 2 will actually be plus 2 when we remove the bracket. We're going to join like terms together, so we have x squared minus 4x minus 5x is minus 9x plus 2. And so x squared minus 9x plus 2 is the difference between the first term and the second term in terms of x. Then we're going to find the difference between the third term and the second term in terms of x. So we're going to do the same thing. We're going to write down the third term, which is 5x squared plus 3x. And then from that, we're going to subtract the second term, which is x squared minus 4x. So as before, we have the second term in a bracket to make sure that we subtract both the x squared and the minus 4x. So we have 5x squared plus 3x minus the x squared, and then minus 4x is plus 4x. And as before, we're going to simplify the terms by joining like terms together. 5x squared minus x squared is 4x squared. 3x plus 4x is plus 7x. And so the difference between the second term and the third term is 4x squared plus 7x. So up to this point in the question, we wouldn't have known that it was a linear sequence, but they say that if this is a linear sequence, show that 3x squared plus 16x minus 2 is equal to 0. So we're actually going to do this over on the side to make a bit of space. There's actually not a lot of space to do this question in the box, but we've established already that in a linear sequence, the difference between each of the terms is the same. And so we can say that if we take the third term and subtract the second term, which we've done already, that should be equal to the second term minus the first term. So the difference between each of the terms is equal, and so if you subtract the second term from the third term, that should be the same as subtracting the first term from the second term. And we have these things worked out. We know that the third term minus the second term is 4x squared plus 7x, and we know that the second term minus the first term is x squared minus 9x plus 2. So how are we going to show that this is equal to 3x squared plus 16x minus 2 equals 0? So let's bring all the terms to the left hand side. So we're going to subtract an x squared from both sides. we're going to add a 9x to both sides, and we're going to subtract a 2 from both sides. So we're just basically bringing the terms that are on the right hand side to the left hand side by changing their signs. 4x squared minus x squared is 3x squared, 7x and 9x is 16x, and then minus the 2 equals 0. So if you can fit this in the box, that's great, that's where it should go, but I just went onto the side to give us a little space. Now, the last part of the question is pure algebra, so we're asked to then solve this equation, 3x squared plus 16x minus 2 equals 0. And just to, again, make sure that I have enough space, I'm just going to do this on the right-hand side. This is a quadratic equation, so let's first of all just write down that that's what we're trying to solve, so quadratic equation. Generally, there is two methods we could use to solve a quadratic equation. We could use factorizing if the quadratic expression factorizes, which this one doesn't, and we'll see why in a second. And if not, then we can use the quadratic formula, the minus b formula. Now, the minus b formula is the method we're going to use because this doesn't factorize. And the hint in the question that it doesn't factorize is that we're told that we want an answer to 3 decimal places. And generally, when they ask you to give an answer to a certain amount of decimal places, when it's a quadratic equation, this normally means we're going to have to use the minus b formula. So let's write down the quadratic, 3x squared plus 16x minus 2 equals 0. So let's write down the minus b formula, which tells us that x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So generally a quadratic equation will have two answers. It's possible that they can have two equal answers, and it is possible that a quadratic equation can have no possible solutions. But generally we have two, and the way we get to is that we have this plus or minus here. So towards the end of the sum, we split this up into a plus and a minus, and we get two separate answers. So we have to assign the a, b, and c using the quadratic equation. And so the way we do that is we say that the a will be the coefficient or the number next to the x squared. So in this case, that's 3. The b will be the number or the coefficient of the x. So in this case, it's 16. And then the c is the term in the quadratic expression or equation that's independent of x, that has no x part. And so that's going to be minus 2. So let's go over to the side here and sub these values in. So write down the formula again. So we have x equals minus b plus minus the square root of b squared minus 4ac all over 2a. And as we fill it in, we'll just, watch out for a couple of mistakes that people generally make with these. So x is equal to minus b. So b is 16. So this one is going to be fairly straightforward. You have to be careful when the b is a negative term, because then we have a minus b, which will turn into a plus. So just be careful there. Plus or minus the square root of b squared, which is just 16 squared. And again, just be careful. Put that 16 in a bracket. It won't matter in this question where it's a plus 16, but if that was a minus 16 and you don't put it in a bracket, you can make a mistake there. Minus 4 by a, which is 3, by c, which is minus 2. And that's all over 2 times a, which is 2 times 3. So we'll go down to the next line. So x is equal to minus 16 plus or minus. Now, I would put 16 squared minus 4 by 3 by minus 2 all in the calculator, this piece here. It is possible or okay to write down that that would be the square root of 16 squared, which is 256. Minus 4 by 3 by minus 2 is plus 24. But the reason I say do it all at once, so let's make a smaller square root and have the root of 280, is because sometimes people make mistakes with the signs in the second part of that piece under the square root. So they just make, sometimes make a little bit of a mess of that bit. And the way to avoid that is find out 16 squared minus 4 by 3 by minus 2, put all that into the calculator, and then put it under the square root. So that's all over 2 by 3, which is 6. And at this point, I would separate this into the plus version and the minus version. So we are going to have x equal to minus 16 plus the root of 280 over 6. And then we'll split it into the other answer, which is x equals minus 16 minus the root of 280 over 6. Another small mistake to watch out for is when people write down the formula, it's important that the fraction is kept all the way to the bottom. Sometimes people split the fraction. This line has to go across the width of the sum here, and at no point should we kind of shorten that. Sometimes you see people near the end just put the square root over the 6, and they forget that the number in front here, minus 16, that needs to also be included in the numerator, the top part of the fraction. So just a couple of little things to watch out for when you're doing the minus b formula. So at this point we take out the calculator and we're just going to put in each version. So we have minus 16 plus the root of 280 over 6. Press equals, and because we're looking for an answer to a certain amount of decimals, press SD. And to 3 decimal places, this is going to be 0.122. So x equals, oh, we don't want the multicolored pen for that one, let's get black. So x equals 0.122, so 3 decimal places. And then let's put in the other answer, and the other answer is very easy to put in because all we have to do is backspace to where the plus is and delete and change that to a minus. Press equals, SD, and we have minus 5.455, but then the next number is 5 or bigger, it's a 5, so we have to round up, and so it's going to be minus 5.456. So minus 5.456, and again, just make sure, the question says 3 decimal places, so just make sure to put it in 3 decimal places. So a nice little question that mixed patterns with algebra. We talked about the different types of patterns, the linear, the quadratic, and the exponential, and we finished with a minus b formula, which is a really, standard and important question that appears a lot on a junior cert paper, and indeed going forward when you're in Leaving Cert, the minus b formula is crucial to solve quadratic equations where they can't be factorized.